Hey there, science fans! Welcome back to another exciting episode where we explore the wonders of technology and science. Today, we're diving into the fascinating world of thermal management. This is a crucial field that ensures our machines and systems operate efficiently and safely. It's all about controlling heat in machines and systems. Without proper thermal management, many of our everyday devices would fail or become hazardous. Ever wondered how chemical plants maintain optimal temperatures in their processes? These are perfect examples of thermal management at work in industrial settings. It's thanks to clever devices that manage heat flow. These devices are designed to transfer, dissipate, or absorb heat to maintain optimal operating temperatures. We're talking about heat exchangers, evaporators, condensers, and cold traps. Each of these components has a specific function in the thermal management process. Each of these devices plays a crucial role in various systems, ensuring that everything from industrial machinery to chemical processes run smoothly. From maintaining optimal temperatures in chemical plants to enabling complex industrial processes, thermal management is everywhere. They may sound complicated, but don't worry, we'll break it down together. We'll explore how these devices work and why they're so important. In this exploration, we'll unravel the mysteries behind these thermal wizards. You'll see how heat exchangers transfer heat between fluids, how evaporators absorb heat, and how condensers release it. We'll learn how they work, their unique purposes, and how they impact various industrial processes. From chemical plants to manufacturing facilities, thermal management is at play. Get ready for a journey into the heart of thermal management. We'll take you through various systems and show you the incredible technology that keeps our industrial world running smoothly. Let's start with heat exchangers, the unsung heroes of thermal energy transfer in industries. Imagine two fluids, one hot and one cold, flowing side by side in a chemical plant. A heat exchanger acts like a thermal bridge, allowing heat to transfer from the hotter fluid to the colder one without them ever mixing. Think of it like this. You have a hot cup of coffee and a cold glass of water. You wouldn't mix them, right? A heat exchanger is like a special barrier that lets the heat from your coffee warm up the water without actually combining them. In industrial settings, this process is crucial for efficient thermal management. Pretty neat, huh? Heat exchangers come in all shapes and sizes, each designed for specific tasks. Some use tubes within shells, others rely on plates, and some even use fins to enhance heat transfer. In chemical plants, heat exchangers play a crucial role. They are used to transfer heat between different process streams, ensuring optimal reaction conditions. For instance, they can cool down exothermic reactions or preheat reactants. This helps in maintaining the efficiency and safety of the processes. Understanding the specific applications of different types of heat exchangers is essential for optimizing industrial processes. Now, let's talk about evaporators, the masters of transformation. Their job is to turn liquids into vapor using heat. Imagine a pot of water on a stove. As the heat increases, the water molecules get energized and escape into the air as steam. That's evaporation. In an evaporator, a liquid refrigerant absorbs heat from its surroundings. This absorbed heat causes the refrigerant to vaporize, effectively cooling the surrounding environment. Think of your refrigerator. The evaporator sits inside, absorbing heat from the air and cooling your food. The refrigerant, now in vapor form, moves to the next stage of the cycle. In chemical plants, evaporators play a crucial role in various processes, ensuring efficient transformation of liquids into vapor. Section 5. Condensers, from vapor to liquid. Once the refrigerant has absorbed heat and vaporized, it moves on to the condenser. The condenser's role is like the evaporator's opposite. It turns vapor back into liquid. It does this by releasing the absorbed heat to the surroundings. In chemical plants, condensers are crucial for converting vapor back into liquid. Remember the warm air you feel blowing from it? That's the heat being released as the refrigerant vapor inside condenses back into a liquid. This liquid refrigerant is then ready to cycle back to the evaporator and repeat the process. Section 6. Cold traps, guardians of vacuum systems. Next up are cold traps, the guardians of vacuum systems. In many industrial processes, especially in chemical plants, it's crucial to maintain a clean, contaminant-free environment. That's where cold traps shine. They act like super-cooled traps that capture unwanted vapors and particles. Picture a cold winter day when you exhale and see your breath. The cold air causes the moisture in your breath to condense into tiny droplets. A cold trap works similarly, but at much lower temperatures, trapping even the tiniest particles. Cold traps are vital for maintaining vacuum systems, ensuring the integrity of industrial processes in chemical plants. Section 7. Differentiating between condensers and cold traps. You might be thinking, wait a minute, condensers and cold traps both involve condensation. What's the difference? That's a great question. While both use condensation, their purposes are different. Condensers are primarily designed to change the state of a refrigerant from vapor to liquid as part of a continuous cycle. Cold traps, on the other hand, are specifically designed to capture and remove unwanted substances from a vacuum system, preventing contamination. Think of it this way. A condenser is like a water cycle, constantly changing water between liquid and vapor. A cold trap is like a net, catching and holding on to impurities. Section 8. Summary and comparison. A closer look. Let's recap what we've learned about these incredible thermal devices, their functions, mechanisms, and real-world applications in chemical plants. Device function, how it works. Example, heat exchanger. Transfers heat between fluids, uses a conductive barrier to facilitate heat flow. Car radiator, HVAC system. Heat exchangers are crucial in maintaining optimal temperatures in various systems, ensuring efficiency and safety in chemical plant operations. Evaporator vaporizes liquid using heat, absorbs heat, causing the liquid to change state. Refrigerator evaporator. Evaporators play a vital role in cooling systems, transforming liquids into gases by absorbing heat, which is essential for refrigeration and air conditioning in chemical plants. Condenser. Condenses vapor back into liquid, releases heat, causing the vapor to change state. Refrigerator condenser. Condensers are indispensable in converting vapor back into liquid, releasing heat in the process, and are found in many cooling and heating systems within chemical plants. Cold trap captures residual particles in a vacuum, uses low temperatures to condense and trap substances. Vacuum system in a lab. Cold traps are essential in laboratory settings, capturing unwanted particles and ensuring the purity of the vacuum environment, which is critical in chemical plant operations. These devices, working individually and together, form the backbone of countless systems we rely on every day. From the HVAC systems that keep our homes comfortable to the refrigeration units preserving our food, and the industrial processes that power our factories, these thermal devices are integral to modern life. Understanding their functions and mechanisms helps us appreciate the complexity and efficiency of the systems that support our daily activities, especially in the context of chemical plants. Section 9. Concluding thoughts. The significance of thermal devices. That's a wrap on our exploration of heat exchangers, evaporators, condensers, and cold traps. These devices, though often overlooked, are the unsung heroes of thermal management. We've seen how these devices, each with its unique mechanism, play a vital role in managing heat and phase changes in various applications. Whether it's in large-scale industrial settings, chemical plants, or in the comfort of our homes, their impact is undeniable. From keeping our homes comfortable to enabling scientific breakthroughs and optimizing industrial processes, these devices are integral to our daily lives. Imagine a world without air conditioning on a hot summer day or a refrigerator to keep our food fresh. It's hard to picture, isn't it? These thermal management heroes are essential to our modern world. They ensure that our environments remain livable and our industries, including chemical plants, continue to function efficiently. Without them, many of the conveniences we take for granted would simply not exist. Understanding their functions and appreciating their importance empowers us to better understand the technology that surrounds us. It also highlights the incredible engineering and scientific advancements that have made these devices possible. So next time you encounter a refrigerator, an air conditioner, or any other thermal device, or even a scientific instrument, take a moment to think about the complex processes at work. These devices are not just machines, they are marvels of modern engineering. Remember the intricate dance of heat and phase change happening within, a dance that is crucial for their operation. This dance is what keeps our food fresh, our homes comfortable, and our scientific instruments functioning. Thanks to these remarkable devices, we can enjoy a higher quality of life and continue to push the boundaries of science and technology. Stay curious, science fans, and never stop exploring the wonders of thermal management.